right, so we're going to take a look at how to use the sum and difference identities. These will be the steps that you generally need to follow. All right, so the restriction is going to tell you where it is. So this is between 90 and 180. That's where the triangle is going to be. So you draw a line between those 2 points. All right, then you use your reference angle. So that's going to be the one that's closest to the x-axis. All right, now label it opposite, hypotenuse, and adjacent. So opposite the angle is O, opposite the 90 is hypotenuse, and the other one is adjacent. Use SOHCAHTOA. So SOHCAHTOA, given that you're given cosine, that's A over H. So A is 3, H is 5. Label it. Then use Pythagorean theorem to find the missing side. So A squared plus B squared equals C squared. Fill in what you know. So 3 squared plus B squared equals the hypotenuse squared. So you're going to subtract 3 squared from both sides. You're going to get 25 minus 9, which is 16. And then square root that. You're going to get B is equal to 4 and label it. So that's going to be the biggest part of this unit, is labeling your triangles. And then you're going to use that to answer the question. But first you have to get used to it. All right, go ahead and do example 2. You'll do example 3. Let me do example 4 because that one's a little bit harder. So looking at example 4, so what's my restriction? Between 90 and 180. So when I draw my triangle, it's going to be between 90 and 180. Remember, the reference angle is closest to the x-axis. Label O, H, and A, and then use that to fill in the side. So we have cosecant x. Okay, so what is cosecant x? This is a listening check. Put a box around example 4. It's going to be 1 over sine x. So that means that you just take the reciprocal of what you're given. So it's going to be 5 over 13 will be sine x. The reason I do that is because I'm going to label my triangle. So sine x is 5 over 13. Okay, now I'll label my triangle. So using SOHCAHTOA, sine is O is the first number and H is the bottom number. So opposite is 5 and H is 13. Use Pythagorean theorem to find the missing side. So A squared plus B squared equals C squared. Fill in what you know. 13 squared, 5 squared plus B squared. All right, so that's 13 squared minus 5 squared. 169 minus 125 is 144. Square rooted is 12. All right, so you have to get very good at doing that because that's just the basics. All right, we have tan, and we have it between 270 and 360, so that's where you're going to draw your line. Reference angles closest to the x-axis. Label it O, H, and A. Okay, then tan is O over A, so the top number is opposite, the bottom number is adjacent, so label it. Use Pythagorean theorem to find the hypotenuse. So that's A squared plus B squared equals C squared. That's 3 squared plus 4 squared equals C squared. So C is equal to 5. Okay, now we're going to use the identity to find tan of x plus y. So looking back at the formula, tan of x plus y. So plus is the top number. So you're going to write it out. So it's going to be tan x plus tan y. Don't use A or B. So it's tan x since they're using x and y. All right, and then going to be 1, and then tan x, tan y, and then I'm going to go look at the sign. Since we are using positive, positive is the top one, so it's going to be plus and minus. This is a listening check. Color in the page number. All right, so let's go ahead and fill in what we know. So what is tan x? Okay, so looking at the x1, so that's the first one is the x. Let's write it in terms of tan, which is what? O over A, right? So the opposite is going to be 5, and the adjacent is going to be 12, even though you can't see it. Just look at your notes. All right, now you need to decide what quadrant it is. Remember, all students take calculus, right? Our line is in the second quadrant, and the only thing that's positive is sine, so tan is negative. All right, that one is tan y, so we've got tan x, tan y, and that's all we need. So let's fill in what we got. So tan x is negative 5 over 12. Plus tan y, which is negative 3 over 4, all over 1 minus tan x, and tan x is negative 5 over 12, times tan y, which is negative 3 over 4. I'm going to simplify this fraction. Before we can simplify, we obviously need to make the denominators the same. So making the denominators the same, I can make this one, if I multiply that one by 3 on the bottom and on the top, I'll get 12 on the bottom. So let's do that. So I'm going to get negative 5 plus negative 9 over there. So that's going to give me negative 14 over 12, all over 1 minus. And since this is multiplication, the denominators don't have to be the same. Just multiply the numerators. So that's going to be positive 15. Multiply the denominators. 12 times 4 is going to be 48. All right, now in order to add and subtract, we need to have the same denominators. Make it 48 by multiply bottom and top. So you're going to have 48 minus negative 15, so that's add-in, that's going to be 63 over 48. Keep, change, flip. So keep the first one, change the multiplication, flip that last one. All right. Before I multiply, so my numbers are not big, I'm going to simplify. 12 goes into 48 4 times and into 12 one time. I can't simplify anymore, so now I'm going to go ahead and multiply this out. And negative 14 times 4 is negative 56 over 1 times 63, which is 63. Okay, so this is a listening check. Make sure that it is negative 56 over 63. All right, let's take a look at example 5. I'm going to make a correction. A is 9 over 40. Okay, so A is 9 over 40. Tan A is 9 over 40, sorry. All right, so again, we're going to draw our triangle. Since they're both positive, okay, we can just draw any triangle. Right, so Katoa. All right, label, so that's O over A, so that's 9 over 40. Again, make that fraction tan A 9 over 40. All right, so using Pythagorean theorem again, so you have the two shortest sides added together squared. That's going to give you C is 41. We're going to do cosine of B. So cosine is ka. So the top number is A, bottom number is H. So go ahead and label that. All right, use Pythagorean theorem to find the third number. All right, so 53 squared minus 28 squared. Put that all in the calculator. You're going to get A is equal to 45. All right, so given that, what is cosine of A plus B? Well, according to the formula, A plus B is going to be the top one, so it's minus. So it's cos, sine, minus sine, sine. So cosine A, cosine B, minus sine A, sine B. And those numbers are going to be cosine. So cosine of A is what I need to find. I don't have it, so I need to write it down. So cosine of A, this is A, and that's going to be A over H. So A, 40 over H, 41. Sine of A is O over H, so O is 9, H is 41. And we're going to do the same thing. We already have cosine of B, so we just need sine of B, O over H, so 45 over 53. So now that we've written all that out, we just need to put the fractions in. So cosine of A is 40 over 41 times cosine of B, which is 28 over 53, minus sine of A, which is 9 over 41, times sine of B, which is 45 over 53. Okay, then we're going to go ahead and multiply these fractions. And you just put that in a calculator. It'll be multiply numerators 1120, multiply denominator 2173. Same thing on the second part, multiply numerators 405, the denominator 2173. Because the denominator is the same, we can go ahead and subtract the numerator and keep the denominator. The numbers are going to get a little funky, but don't worry, they're still right. All right, so let's take another look at another one given radicals. This is in quadrant 1. What you know about quadrant 1 is going to be positive. Okay, so you're going to label your triangle just like always. All right, so opposite and adjacent is what you're given. So that's 5, and hypotenuse, I'm sorry, is radical 29. On the second one, you're given tan, which is over A. So opposite is 1, and adjacent is 1. Use Pythagorean theorem to find the third one. So it'll be the hypotenuse minus one of the sides squared is B squared. So that's 29 minus 25, which is 24. Square root is 2. All right, same thing here. So 1 squared plus 1 squared equals C squared. That's going to be radical 2. Okay, so just using Pythagorean theorem. All right, now once you have that, we're going to do sine of x minus y. So we're going to look back at the formula to see how to write that out. So sine of minus will be minus. So sine A cos B, cos A sine B, and it's a minus. So sine x cosine y minus cosine x sine y, just according to the formula. Now we're going to put in what those are. So to find that out, we need to find what sine x is, what cosine x is, what sine y is, what's cosine y. All right, so we're given sine x, so that's 5 over radical 29. We need cosine y, so I'm going to find cosine y. Cosine y would be a, which is 1 over h, which is radical 2, so that's 1 over radical 2. Cosine x will be ka, which is a, which is 2, and h, which is radical 29. And then sine y would be O over h, that's 1 over radical 2, which is h. This is a listening check, color in sine y. Okay, and then now you just have radicals, right? So again, multiply. So we're going to get 5 on the top, and this is radical 58, because just multiply 29 times 2. Multiply the top, multiply the bottom. And because they're the same, I can subtract. So that's going to be 3 radical 58. And of course, you can't have a radical in the bottom. So you got to multiply top and bottom by radical 58. So it's going to give me 3 radical 58. And then 2 radicals that are the same multiplied together just give you the number inside, so 58. Now I'm going to just check to make sure I can break down the radicals, simplify. 2 is a prime and 29 is a prime, so there are no books to take out, so that's it. Let's practice.